Okay, for example 3, we're given an angle, or sorry, parallel lines M and N. So those two lines are parallel. Again, if I don't have this picture drawn, I want to draw the picture. Right? They are referring to things as angle 1 and angle 2, so preferably the picture should be drawn. But what we're trying to prove here, if you look at 1 and 2, those are alternate interior angles. So we're trying to prove the alternate interior angles theorem. All right? We can't use the alternate interior angles theorem to prove the alternate interior angles theorem. Right? Just you're not allowed to use the same theorem you're trying to prove it. So you have to use other means, other theorems, other postulates to do this. So, first off, I'm given parallel lines. I always start my proof with a given statement. So I'm going to write 1 angle, or line M is parallel to line N because that's given. Okay. Since that's a freebie, I went ahead and wrote it down before I even started thinking about how to do this proof. All right, I usually put some thought process into my proof before I actually write it down. That way I don't have to rearrange the statements and make a big mess of my paper. So, see if you guys buy this line of logic. Can we all see that 2 and 3 are a linear pair? So 2 and 3 out of 180, right? 2 and 3 out of 180? Does something else add up to 180?
2 and 1.
2 and 1 are equal to each other. That's what we're trying to prove.
Oh,
Three
yeah,
and one.
that's
No,
Saying
3 and 1.
3 and 1 have to add up to 180 because they're the same side interior angles, right? Or consecutive interior, the way I named them before, right? So 1 and 3 add up to 180. 2 and 3 add up to 180. We have two different things adding to 180, so they equal each other. 1 and 2 get in the same equation. We're probably in good shape then, right? So again, thought process, just enough to start writing the stuff down to get us kind of on the path to where we're trying to get to, which is this fact, congruent angle. So if I start with that fact, I know for number 2, I'm going to say measure of angle 2 plus measure of angle 3 is equal to 180 degrees. And the reason for that is that two angles that form a linear pair add up to 180, or a straight line has 180 degrees in it. One of those things that we've said before. So I'm going to say 180 degrees in a straight line. For number 3, we're going to say measure of angle 1 plus measure of angle 3 equals 180. That's because the consecutive interior angles postulate, I believe, is what it is. My iPad's making weird noises, sorry. Turn the volume off at some point. So number 3, this is a postulate that's in your book. It's postulate 2.1, same side interior angles postulate. If transversal intersects two parallel lines, then the same side interior angles are supplementary. That's the postulate. All right, I can write all those words. I can just say the same side interior angles postulate. So, same side interior angles postulate. In case I didn't mention this the other day when you were working on this, these sheets with all the theorems and postulates are usable during quizzes and tests. So all your postulates will be right there for your viewing pleasure during a quiz or test. All right, kind of know where they are, kind of be familiar with them, but if you need something, flip it through it. And again, the picture is really helpful in those things. The picture looks exactly like that to demonstrate what's true in case you're unsure what the vocabulary means. All right, so 1 and 3 out of 180, 2 and 3 out of 180. Again, with equations, this happens quite often. Two things equal the same thing, so they equal each other. That's substitution. So I'm going to go with substitution to say measure of angle 1 plus measure of angle 3 must equal measure of angle 2 plus measure of angle 3. I put this expression in place of that 180 because that equals 180. And that's all substitution is. It's either that one or where you just put something into an equation. So number 4, substitution. So our task is to prove 1 and 2 are congruent. Right now we've got 1 and 3 measures equal 2 and 3's measures. We have equality happening here. Whenever we have an equation, something equals something, we're allowed to add, subtract, multiply, divide, anything we feel like at any time we want to. And right now, angle 3 is in the way, right? I want 1 equals 2. I don't want any angle 3's in here. I got an angle 3 on both sides, so I'm going to subtract angle 3 from both sides. So step 5 is going to say measure of angle 1 equals measure of angle 2. And again, I made that happen by subtracting angle 3. So that's the subtraction property of equality. Not going to fit. And finally, anytime I want to prove congruence, I first have to prove equality. Once they're equal, they're congruent. Definition of congruent angle says if two angles are equal, then they are congruent. So, number 6, I'm going to say angle 1 is congruent to angle 2 by the definition. Let me show you some abbreviations here. That's the abbreviation for definition. Defin. There's lots of definitions, so if you give me a defin, I'll know you mean definition. Definition of congruent angles. Check out how I spelled congruent angles there. I like the logic involved in proofs. I don't like all the writing, so I'm fine with some abbreviations as long as they're very clear, understanding abbreviations. So if you want to spell congruent equals with a little tilde over top of it, that's fine. If you want to spell angles with an angle symbol S, I'll know what you mean. So again, feel free to abbreviate things. Just make sure that your meaning is clear in your abbreviations. Don't abbreviate so much. Like SPOE, subtraction property equality, that'd be a little bit too abbreviated. So that's the whole proof. Started with the given information, used law of detachment again and again and again and again and again until we got to where we wanted to get, which was the angles are congruent.